Hello there people, this is Christian. Welcome back to my computer and Fusion 360 and this sphere that is created from sheet metal segments. This design you're looking at here is a bit broken, so we're going to do a new design later, but just want to show some of the ways I'm thinking here. So if we isolate one of the segments and look from the front, this is simply an arc shape. This is like a half circle, but for sheet metal parts, we need to remember one thing. If you're going to create this manufacturing in the real world, we're going to activate the section analysis. I've sliced the sphere down the middle, and we'll look from the top. Let's look from the top. You can see that you get the inside is touching, but the outside there's a small opening. That is because if you're going to create this as a flat part, you normally cut this cut here. That's the cut you're going to cut when you cut the part from a larger part of sheet metal. That is normally perpendicular to the flat front face here, so you need to fill that up. In this case, I've exaggerated the thickness a bit to the size of the sphere, so that's view. And as I was saying, the final product we want is this flat pattern. We can export and create the sheet metal parts. And I've added a sketch here with 2 driven dimension and made it visible so I can have a fast look at how large the sheet metal part of the starting sheet metal what I'm starting with, the plank need to be in size, so I can put these on there. So I'm going to finish that. So we're going to hide that and go over to our new design here. I've done a save. First thing I'm going to do is create a new component. If you're working with sheet metal parts, you want each sheet metal part in its own components because you can only have one flat pattern in each component and so forth. You're going to export them. So I'm simply going to call this segment. And we're going to have 2 parameters. We gonna have our sphere diameter, the outside diameter sphere. Let's do it 300 millimeters for the fun of it. We need to know how many segments we want. Segment count. The important part here, of course, is make sure it's no units. As this is 12. Gonna hit OK. Open up our component. And we're gonna create a sketch from the top. Start with a circle. Gonna make it X as a construction circle, hit X of the keyboard or hit out here. And this is gonna be our sphere diameter. And then gonna start doing some lines. Turn off construction for now. Gonna make a line out here. So this is like one sector. Gonna go down and go in here again. And just to make it a bit easier to see and avoid this flashing profile, I'm gonna turn this line into a construction line. I'm gonna make this only horizontal vertical, that's correct. I have a small problem which moves around. I could add a line out here and make it symmetric and stuff like that. There's another option. I do a line once again, L of a keyboard, construction line from here, that intersection of a circle line, intersection of a circle line, until Fusion I want that to be vertical too. We can use parallel. This locks this into be symmetric around the center line here of the plane I'm going to use later. Once again, D for dimension. We're going to dimension the angle, 306 degrees, divided by the count we have. And this here needs to be tangent to the sphere. So this is going to basically be the face of the sheet metal segment. So these corners are going to be slightly outside the desired sphere, but that's just how it works when you design something like this. So with that said, I'm gonna finish sketch, create a new sketch from the front here. I'm gonna do a projection of this line here. Gonna make an arc, create, you can find arcs here, you can use S on the keyboard and type in arc. So I'm gonna make a 3-point arc simply like this. Gonna do a midpoint. This is a bit of trick to get the flat pattern to work. Coincident between the center point of arc and the center of a sphere. And then I'm doing the two lines, construction line. Gonna start here at the arc, back here and here. So the obvious would be to just simply make this horizontal vertical like this. But there's a small problem with the flat pattern. It gets confused. I don't know why, but you make it perfectly 108, perfect half circle. the flat pattern will fail. I need to do it slightly offset, and it's a really small offset. Dimension these two lines. Dimension of angle 179.99. So it's really close to 180, but it's not 180 degrees. The flat pattern will then fail if you do that. Finish sketch. And now we're gonna just have a look. Our sketches are fully defined. Jump over to the sheet metal tab. You're gonna create a flange. Select our arc. Select, I like to work from the bottom up sometimes. Start by selecting appropriate rule. I'm simply going to do aluminum in millimeter. It's not millimeter in my rules for some reason. I haven't need to check that more out why it's not working correctly. New body, yes, we need to do it symmetric. Orientation, we're going to have a look at the distance. I'm simply just going to use the sphere dimension or sphere diameter. Now we're going to have a look at orientation. We look from the front and zoom in. We can see that Fusion right now is putting the sheet metal part on the outside. Here's a thing example. Oh, there's a straight line. It's not following the arc. Yeah, Fusion does that for performance. The arc's going to be perfect, but just for graphic performance, it's simplifying the sheet metal part into segments right now. Anyway, as I said, sorry, sidetracked. This is on the wrong side, so we're going to do this on side 2. So the sheet metal part is on the inside, and I'm pleased with that. I'm going to hit OK. And obviously this part is just too big. Here are some, we can do some different options here. We can create a sketch and then extrude away. This is one option to do. Jump over to the solid tab. We're going to cut out so we only are left with the pie part we need. Modify, split face, select the face that is the correct one, is the inside face, not the outside face. Splitting tool is going to be our 2 lines. I'm going to hit OK. I'm going to hide the sketch to make it a bit easier. So we only want this part. We could create a new sketch and project in and then extrude stuff, but I'm going to make it a bit, it really doesn't work correctly either. So this is the best one I want to do. We're going to do an S and offset, in this case offset face. Offset face is always done normal to the direction of the face we're doing from. So we're going to select these 2 faces. I'm going to do it -5 millimeters, well beyond the thickness. If you know you're going to make it thicker, you might want to do it like 10 millimeters. Let's see if Fusion doesn't cry when I do it like this. Let's do it -10 and hit OK. And you can see we got cut away, so we're just left with the sheet metal part we want. We're going to go back to sheet metal, and just to check that things are working, we're going to make a flat pattern. Select the this sometimes confuses people. If you want to do an unfold is a design tool where you flatten a sheet metal part. You can add geometry and then refold it. Flat pattern is like an output system where you create a flat pattern and export a DXF for cutting and other things, and you can also add things to the sketch you want to export and so forth. But anyway, I'm going to select the outside face. That's an interesting one. I'm going to hit OK. Wait for Fusion to think, and here we have the flat pattern. We can export a DXF and so forth. And for a sanity check, if you maybe you want to see what's going on, I'll create a sketch. Create the top face here, hit P for projects, project in the top point here, D for dimension, and get the dimension from here to here. Of course, it's going to be a driven dimension, yes, and the dimension of its bend line, that's the width of it. I'm going to finish sketch. This makes the dimension disappear, so I'm going to do right click and show dimensions. So this I can very rapidly just simply open the flat metal, the flat pattern part of the sheet metal, and have a look at what dimensions is my part having, how large does the starting sheet need to be able to cut the parts. Finish flat pattern, go back here. Go back to our top level because we want to see how the completed sphere will look. So we go S and circular pattern. This case of object type is components. Select our components, select the axis, and it's the count. The quantity is our segment count, and I can hit OK. And we now have our completed sphere. We can check for font, solid. First of all, check our parameters. We can change the dimension of a sphere to 400. Yes, we can change the number of segments to 15. Of course, the lower number we make, the less of a sphere it's gonna be. Let's just check one thing. We're gonna do inspection. If we inspect from top here, I think I'm clicking on the right points. Yep, it's 400 millimeters. So in that direction it's correct. But if we redo, it's gonna be larger between these two faces. It doesn't want to do in that direction. Show snap points, go back. Can we snap to something on this? Doesn't want to snap any good, but so yeah, but doesn't add the dimension I want to do anyway. But we have to remember, the less segments we have, the less of a sphere it is, of course. Let's go back and make it 12 again. And if we want to change the type of material we're using, you see the flat pattern just got lost, there's no problem. Let's go into our sheet metal, we'll aluminum frame cube, go with sheet metal, and up here we have sheet metal rules. We have the one we have in our design, and we can edit it. And let's say for some reason it's called millimeters, but it's showing the thickness in inches. And I want to change that to 3 millimeters instead. And you can change the K factor. I'm a bit worried about the K factor here. It depends on how you're going to manufacture this. If you're going to roll it as in how it will stretch, you might need to edit this number to get the correct dimension of the flat pattern. That's the thing when you work with sheet metals. Save, close, and now we can do our flat pattern and with update with the new thickness. So now we have a 3 millimeter. Let's check that. That's a 3 millimeter thick. Yes. And we have our dimension, and we can export the flat pattern and do some cutting. So I hope you understand some of the things I did here. And if you're a beginner and gonna say I'm too fast, this is not the beginner's thing to do. I am sorry I said this at the end of the video. I should say that at the start. Anyway, I hope you found something useful in my video. And with that said, take care, see you around, and goodbye.